All right, so today what we're going to do is we are going to look at some shapes. And shapes can be classified as regular or not regular, which is called irregular.
I've lost my calculator.
Okay, you don't need it. And then we're also going to take a little bit of a look into some triangles and some ideas about triangles. And then if we get the time, we're going to talk about estimating angles, right? Just by looking at them and seeing about how big they are. So estimating angles is a big skill. And then later we'll do some measuring, but we'll do that in another lesson. Okay? So we're shapes, regular and irregular, triangles, types, okay? And estimating angles. All right. So let's... Pardon? Yeah, I don't care if you put regular and irregular. Okay, here we go. So, the first shapes we're going to be talking about are polygons. Any 2D shape that has three or more straight sides joined together to form a shape. So, really important aspects from this. They are polygons, simply a word that means many sides, okay? They have three or more straight sides. So if you get a curved line, do you have a polygon? No. Okay? And they also must form a closed shape. Yeah? Voice is finally changing. Good deal. All right. So, polygon. Three or more what? Straight sides. And they must form a closed shape. So your notes need to have polygon, three or more straight side, closed shape. Okay? So, pardon me? We'll look at lots of pictures of them, so don't worry about it. Okay? No. All right. Okay. So, if we say a shape is closed, we mean that all the sides join together. There are no gaps. If you have any gaps, then you do not have a polygon. Excellent. Okay? There are lots of different shapes of polygon. You'll have to copy from somebody else that piece. All right. The name poly comes from the Greek language. Poly and gon means angles, so you're looking for many angles. So we're going to look at what are something called regular polygons first. Okay? So I want you to write down regular polygons. And the definition of a regular polygon is that it has sides of equal length and interior angles that are all the same size. So what you can say is the sides are equal length and the angles are all the same size. That doesn't mean the size of the sides and the angles are the same. It means all the sides are the same and all the angles are the same.
So
okay?
Is that what I said? Regular polygon.
And that's called a regular polygon. Right? Can I have any number of sides?
5.
Okay. All right. So you're seeing different shapes, polygons. What's important is, though, if they're regular, that means that they have the same size of sides and angles. Okay? Right? All right. We're not going to watch the video. It's too childish. Okay, so you're going to have to identify some language about polygons. So let's look at some regular polygons. The smallest polygon that you can draw has something with three sides called a triangle. And triangles have different properties. And the first one that we're going to talk about is something called an equilateral triangle. Okay? Has three sides, and equilateral means all the sides are equal in length. Equilateral, right? Lateral means line or side. Okay? All right. And because all three sides are equal, the three interior, what does interior mean?
Inside.
On the inside, the interior angles are also equal. So equilateral triangles have lots of things that are regular polygons. Therefore, the sides are all equal and the interior angles are all equal.
Couldn't the exterior angles
Okay.
also be equal?
Yeah, but we're not worried about that right now. Okay? All right. The interior angles of an equilateral triangle add up to 180 degrees. But that is not specific to an equilateral triangle. The interior angles of any triangle will always add up to what? 180 degrees.
Why?
Okay, we'll see why actually. They have a little graphic for that. Okay? All right, so equilateral equal what? Sides and equal interior angles. Good. Okay? All right. Squares have 4 sides. Squares are a polynomial called a, what kind of polynomial? There's a big name for it. You usually think of them as rectangles. They are quadrilaterals. Quadrilaterals mean 4. And a square is a special type of quadrilateral. So squares are regular because they have 4 sides that are equal length, right? And all the angles are what? Are 90 degrees for a square. Yeah. Okay?
Okay, give me 2
All right.
seconds to write that all down.
Okay, no worries. And they also talk here a little bit about parallel lines. Parallel lines are lines that travel in the same direction, but they never cross. That means they're the same distance apart always. Okay? And we'll talk about some notation. You'll see that they're giving you some notation here. See the little arrow on it? If you see 2 arrows that are the same, that means that lines are parallel. Now these 2 lines are also parallel, but they use 2 arrows because they are not parallel to the other set of parallel lines. Okay? So if you had 3 parallel lines, you could use the same arrow on all of them. And sometimes they put it in the middle, but they could just as easily put it at the end. Usually, if they're making the point about parallel, they put it in the middle.
So we have to write the parallel then.
Well, you should write parallel lines mean they're in the same direction and never cross, please. Okay? Alrighty then. Oh, come on.
Copy from Poppy.
Pentagon!
I like pentagons.
Pentagon, special kind of shape. It has how many sides?
5.
There you go.
Wait, wasn't that polygon?
Pentagon this time, okay?
What's a polygon?
Polygon is any shape that has more than 3 sides. All right, Pentagon has 5 sides, and that's all you need to really know about that. We'll talk a lot more about them later. Hexagon has 6 sides. Good. So again, this shouldn't be new information for you, but it might have been a while since you've thought about the different names. How about 7 sides? Heptagon. There you go. Hepta means 7. Octagon, 8. Okay, and there are, of course, more. Nonagon, what do you think? Probably 9. There you go. Good. No, that's your homework.
No.
Okay.
Wait, so there was a pentagon and then a hexagon. Then what was the other one?
Okay, the last ones we were looking at were all regular shapes. To this one, we're going to look at some irregular shapes. So this is a combination of a bunch of irregular shapes.
How did they do
Okay.
that?
I don't know. It's magic.
I want something like that.
It's magic. Okay? So, we know the ones that are regular shapes, they have all the same sides and all the same angles. Good. But that does not mean that all shapes are regular. An irregular shape has at least one side that is different length and at least one angle that is different. So, anytime you have an irregular shape, it's at least one side is different and at least one angle is different. Okay? Can it have more than one different?
Yes.
You bet. But it can't be, otherwise it'd be regular if it had. So you see 2 different things there. Both of these things have how many sides? So they are both pentagons. Right? So this is just an example. So they're both pentagons. But one of them is a regular pentagon and the other is an irregular
We
pentagon.
understand the regular pentagons.
Pretty easy?
The regular ones.
Wait, I feel like I should write this down.
Okay? Well, you should write irregular shape and is in Y. Okay. All right.
I'm taking a picture so I can actually write.
Okay. So they're still classified by the number of sides, even if they are irregular. Okay. And here we go. We just went over these. Tri means what? Quad, pent, hex, hept, oct. There you go.
Octopi.
And
Okay.
nonagon. Is that what it's called? A nonagon is that 9 sides?
9. Mm-hmm.
And then what's 10?
Multicon.
That
So here's just some examples of regular and irregular shapes. Again, it doesn't matter that they're irregular; they still have the same names, right? Okay. Good deal. A couple more
the irregular ones.
very odd shapes there. Okay. Now you're going to spend a little time measuring. So when you do your homework, you will be measuring those. Okay. So how can I tell that a shape? One of the most common shapes that we're going to use, we're going to look at triangles. So we're going to look at different types of triangles and their names. Okay, they can be named in two different ways. We can name triangles according to their angles, or we can name triangles according to their, what is the other measurement we like?
Length.
The sides. Yeah, the length of the sides. Okay, so here we go. So they can be based on either their sides. This is important, guys. Triangles can be based according to their sides or the angles.
Did they Photoshop that back?
Okay.
Yes.
No,
No, they got a
the
real
bunny.
bunny.
The bunny drew those triangles, and so they just took a picture of him doing that.
No, I'm
Wait.
What's the tape measure? Oh wait, hold on. I need to write it down.
How are we supposed to know that?
Because I just told you.
So do we have
So
right.
if I draw that and do that, that means those two sides are the
Same.
same. Okay. What if I did that?
They're all the same.
All the same. Okay. All right. And you can use more dashes as well to measure other sides. Now, there are 3 types of triangles that we need to know according to the lengths of their sides. Okay? The first one is scalene. Scalene triangles have no equal sides.
Wait, we have to write this? Oh.
Yes. Scalene have, at least the part that I circle and underline, yes. Scalene triangles have no sides that are equal length.
So are we going to do
Okay.
any examples of this? Or, like, can I just use my
Okay.
high page notes?
Just get more paper. All right. The next type is an isosceles triangle.
That one's very familiar.
Isosceles have exactly 2 sides, not less, not more. Okay? Exactly 2 sides that are the same length. Therefore, they are called isosceles. Okay?
I am already here.
And finally, the last type is equilateral, and we've talked about that briefly earlier. That means that all 3 sides are what? The same. They're all equal. Equilateral.
Do we need
Okay.
to write the thing for the equilateral again, or
Not if you've already gotten it down. It's fine. Okay? Unless you think you need it.
beans?
Okay?
Hold on. Oh, yeah.
All right. So, scalene. What?
No
None.
equalness.
No equal sides of equal. No sides of equal.
No sides that are equal.
Nothing is-
Isosceles.
2 sides.
2 equal sides. Equilateral.
3.
3
All of
equal
the sides
sides.
are equal.
All of them. Good.
I'm already
Excellent.
here. I'm already here.
Isosceles.
Excellent.
Isosceles.
Okay. All right. You need to know which one is which because their classifications are very important. You'll be doing that. Okay? All righty. Here we go. So, scalene. So here's some examples of scalene. You can see that all the lengths are different sides. But normally, you have to be told that they're different, and so they will use those dashes as the notation. So that you'd have something like this. 1 dash there, 2 there, 3 there. Notice each side has a different number of dashes.
Yes.
That tells me that all three sides are different lengths.
Oh, I didn't
All right.
like that.
Okay?
Can you repeat the
Now,
whole
you could also have numbers. And if the numbers are all different, right, those measurements, and they would normally have units, that means the numbers would all be, if they're all different, then the sides are all different, therefore they're scalene. Okay?
You don't explain it. You just
Examples.
Can I go to
Okay.
the bathroom?
Yes, you may. Okay? Now, all right.
Can you look everything down for me? If you look at the
You
menu.
bet.
No, but that's a scale.
Okay.
I mean,
So, here we go, guys. A ramp can be an example of a scalene triangle, but there are lots of other examples. See that the boards are longer than the length of on the ground, which is which is longer than the height of the ramp. Make sense? Okay. Isosceles triangles have two sides that are the same length. Now notice this time they're giving you the dashes and they didn't on the others. If they don't give you the dashes or measurements, you can pretty much assume that it is a scalene triangle. It's the only one they don't have to tell you anything about, and you can assume that means that you can assume that all the sides are different.
So that's a scalene.
Scalene. So these are isosceles, and we know that two sides are the same because again they're doing the little dashes. Doesn't matter if you look at it. Okay, those dashes travel all around, but they really don't. If you look at all of these, if you put them all in the same orientation. Notice that the two equal lines, all I did was redraw those. The two equal lines are always the pointy top, the pointy part, right? Okay? It's never going to be the base, the bottom, that's the same as the other two. They always make a point. Another thing about these is that you could always divide them exactly in half. They are mirror images of each other. That you could fold it in half and it would fold right perfectly onto each other.
Poppy, are you noting this down?
Okay? All right.
Your puppy, but if you
There
know
you
it
go.
down.
It's all right.
My whole
Now.
box came apart.
Okay, there you go. So you have a coat hanger.
Oh, no,
So.
it's fine. You can just copy it from someone.
All right, equilateral triangles have three equal sides. So again, they do the notation to show you that they're all three equal sides. For example, the yield sign. Y'all call it give way. Yield. Yeah. Y'all call it something funny, but really that's
It's a good way. You're giving way to someone else. Not yielding.
you're
I
yielding.
don't yield people.
What is
I think
yield?
yielding is the
Okay,
Yield.
Yeah.
And you also put it upside down. No. So there we go. So there you. So all of the angles are acute, therefore it is an acute triangle. Here we go. All right, let's see.
Aw, he's so cute.
Next.
Oh, you're cute. Apple.
Imagine Frog saying he's so cute to the dog.
There it is. Okay. Then finally, the last one is an obtuse triangle. And again, you're never going to see it as an obtuse angle. They're just trying to stress that it's an angle, but stress that it's an angle. So that has one obtuse angle.
They're trying to stress off.
It cannot have more than one, otherwise it would add up to more than 180 degrees. It wouldn't be a triangle.
Is there scaling?
No. So, and it could also be scalene, yes. But that doesn't have to be. All right? Obtuse has one obtuse angle. Okay? Now, you guys stop being obtuse and listen. All right? So there you go. Acute angles, obtuse angle, triangle angles, and right angles name the different types of triangles. So you're going to have some where you're just going to have to do that. Okay? Then, the last section that I'm going to give you today, guys, the last section that I'm going to give you today is where you have to do both. Name them by their sides and by their angles. Okay? Now notice the angles here. They give you one line Okay? You can use the same convention. If I did 2 lines, so that tells me that measurement is what? Not the same as the other 2.
Okay.
Right? So you can use that same convention if the sides are different. You'll see it later. Okay? All right.
What?
So,
I'll